Okay, so just straight into it. We're going to continue from the last video where we did questions 1 to 4 on the summer test. I'm going to do questions 5 to 8 now. So question 5, you're given two solutions to an equation. So that's a quadratic equation there, and you're told that they are integers. So A, B, and C. So that's these three numbers there are integers, so whole numbers. So when you're given solutions, that means 5 over 2, these are roots. So that means x is equal to 5 over 2 and x is equal to 3 over 5. Now, we want whole numbers here, so we've got integers. So let's just get rid of these fractions. Let's times this one by 2 and times this one by 5. Remember, we always want to get rid of fractions if we can. So we've got 2x equals 5 here, and we've got 5x equals 3 here. So now that we've got the roots, we want to then make these into factors. So this would become 2x minus 5 is equal to 0. So we turn factors are basically the brackets. You know, when you factorize, you make the brackets. So here you have 5x minus 3 is equal to 0. So once you have those, you can just multiply them out. So we get 2x by 5x minus 3. You multiply the two factors to get it, and then minus 5 by 5x minus 3. So just work on like that, multiply them out. You've got 10x squared minus 6x minus 25x plus 15. And combine your two terms here, you get 10x squared minus 31x plus 15. So as you can see, you've got an A, B, C that are integers here. So our A is going to be 10, our B is going to be minus 31, and our C is going to be 15. Okay. Next question then. Oh yeah, I had the hint then. If you get two factors, you can multiply them to get the equation. Okay, so moving on then. You are given a function, and it is defined for x is a real number by this. So this is a complete the square question. Okay, so we need to complete the square. So let's see, what's in common to this? Well, you want something on the outside, and you can see that there's a 2 in front of the x squared. So let's start there. So we've got 2, then we've got x squared plus, sorry, not x squared, 2x plus 1 squared. Now, the reason that works is because x plus 1 squared is x squared plus 2x plus 1. Okay, so it's not 2 by this, it's 2 by the whole thing multiplied. It's not 2 by x and 2 by 1. You have to square it out first. So that will multiply to give us 2x squared plus 4x. So that's good. It's the same as up there. It's 4x and then plus 2. Now, little problem there. We've got a minus 5 stuck here. So we want to get rid of that. So how do we turn a 2 into a minus 5? Well, we're just going to minus 7 off that. So that will work out then as 2 by x plus 1 squared minus 7. Okay, so if you can't figure it out immediately off the bat, just try different numbers for this x plus something squared. Just check if they work out over here, and then you just subtract off whatever you need or add it at the end. So easy enough question, they're quite common. Right, moving on then. Oh, hence find the minimum point. So let's just leave it there. Hopefully it's not too small for your screens. So the minimum point is going to be related to, hang on, I'll rewrite it here, 2x plus 1 squared minus 7. Okay, let's just zoom back in. Right, so our minimum point is going to be related to these two things here. Okay, so x plus 1 squared, that will shift things left. Now, you might think it should shift it right, but it doesn't. It shifts it left. So that means it's minus 1. Okay, and then this is going to be your minimum point. So minus 1, and then you're going to have a minus 7 with it as well, because x plus 1 will shift it over to the left. So you can imagine it being like here, and then it's going to be minus down 7 points. So it's going to go down to there. So our minimum point is minus 1, minus 7. Justify it is where x plus 1 squared is equal to 0. Okay, so that's going to be at this point, and then it will go down there. Okay, and then explain why gx equals 0 must have two real roots. So our gx, remembering from earlier, is 2x squared plus 4x minus 5. Now, if you ever see anything about real roots, you're thinking b squared minus 4ac is greater than 0. Okay, remember that's the discriminant, in the minus b formula where you have the square root of b squared minus 4ac. To be real, it has to be bigger than 0. So here's our b, our a, and our c. So we've got b squared, so we've got 4 squared minus 4 by 2 by minus 5. So 16 minus 8 times minus 5, so 16 plus 40 is 56. So it has to have two real roots because b squared minus 4ac is greater than 0. Okay, so that's actually a fairly nice question. Okay, moving on to question 6. Okay, so we've got a triple simultaneous equation here. So there's always wonderful ways of messing these up as you go along. So just take your time with them and don't be stressing too much. So as you can see here, you want to get two things that are the same. So you can see you have a 1y and a 1y at each of these points. So let's use that first. So we've got x plus y, and then there's no z is equal to 2. Then we've got y plus 2z equals 12. So lay it out nicely when you're doing this. Okay, then you can just do like this. So your y's will minus off each other, so change your signs. And we're going to get x minus 2z equals minus 10. Okay, that works out. So that's one of your things. So remember, you need to do this twice. So we've got rid of y, we need to get rid of y again. Now, that's a 7y, so let's times the first one by 7. You'll get 7x plus 7y plus no z is equal to 14. And you'll get 5x plus 7y plus z equals 13. Again, we're going to do the same thing where we're going to minus off the bottom. So we'll change the signs because the signs are the same. And you are going to get 2x. These are gone. So minus z equals 1. Now we have two new equations here. Okay, so now we can just do a normal simultaneous equation, not a triple simultaneous equation. So let's move this one under here and we'll multiply it. To get rid of the x, let's just multiply it by 2. Okay, right, so we'll have another 2x here and we'll have a minus 4z equals minus 20. Okay, we're working with big enough numbers. Again, you see the x's are the same, so let's change the signs. Minus, that'll become a plus, and that'll become a plus. They're gone, so we get 3z equals 21. That's always a good sign. You see they divide, so let's just divide by 3. And you will get for your first answer, z equals 7. Okay, now that you've got one, you can work out the others fairly easily. So we can just use this. So we've got 2x minus z. So we'll use this one because that's the easiest one. So we've got 2x minus 7 now equals 1. So plus 7 to both sides. You can probably work it out in your heads all right. We get 2x equals 8. So x is equal to 4. Lovely. And let's just use this for our x. We've got 4 minus 2. Sorry, we've got x and z. We need to use our x and y one. Let's use this one here. So we've got 4 plus y equals 2. But obviously 4 minus 2 equals 2. So that means that y equals minus 2. Okay, maybe not the nicest layout ever, but you see, you knock out one variable and then just work with the others. So our final point is, because it's a 3D plane, although that's kind of beyond leave insert, our point is 4 minus 2, 7. That's our x, y, z. Okay, those can take a while, so all good. Right, 2x plus 3 is a factor. Okay, if you're given a factor of something that's big like that, chances are you need to do some sort of long division or some other method that's like that. So let's just go straight into this. 2x plus 3, and let's make another one. 4x cubed minus 12x squared minus 7x plus 30. Okay, so using this information, you can find 3 solutions. So one of our solutions is going to be using this. And then you're going to make a quadratic by long dividing, and you will get the other here. So standard long division, 2x multiplied by 2x squared. It's going to give you 4x cubed, then multiply that back down. So we will get 4x cubed plus 6x squared. All right, minus these off. So minus and minus, you will get minus 18x squared there. And then you will bring down your minus 7x. Now repeat the process. 2x times minus 9x will give you minus 18x squared. Then multiply it back in there, and we'll get 9/2 is minus 18x squared. 9/3 is minus 27x. Same method again. Let's just change the signs. We've got a plus and a plus now. So minus 7 plus 27, those will be gone. So this will give you now 20x, and you need to bring down your plus 30. 20x plus 30. That will divide in nicely. 2 by 10 gives you 20, so that will be a plus 10 up there. And you can multiply it back in if you want, but you will just get again 20x plus 30. And that will be gone. So that is a good job. We have got this right. Now, so what we have got now is 2x plus 3 times 2x squared minus 9x plus 10. Right, again, we're stuck with only, we want this to be 2 brackets. So that means we're going to have to factorize using our guide number over here. So our guide number is 2 by 10, which is 20. So we've got 1 and 20, 2 and 10, 4 and 5. Which of them is going to have to be minus 9? It'll have to be minus 4 and minus 5. So let's just factorize this. 2x squared minus 4x minus 5x plus 10. So 2x by x minus 2 minus 5 by x minus 2. So our new bracket will be 2x minus 5 and x minus 2. And that bracket isn't going to change. That's 2x plus 3. Okay, so remember this whole thing was equal to 0 back at the start of the question. I'm sure you can see it on your page. So we've got 2x plus 3 equals 0, or we've got 2x minus 5 equals 0, or we've got x minus 2 is equal to 0. So kind of your graph is like this, and there's going to be 3 places where it's touching, the 0 points. So you just move these over and divide by that. So this will be x equals minus 3 over 2. What you do is you minus 3 from both sides, so it'll be 2x equals minus 3, then divide by 2. So you minus 3 and divide by 2. I'm just going to go through it quickly because I know how long these videos are. Here we're going to have x equals 5 over 2. Again, moving over, and here just x equals 2. Okay, so those are your 3 answers. They're down at the bottom there. I'm not going to bother rewriting them. You've got minus 3 over 2, 5 over 2, and just 2. Okay, so long divide and then factorize. That's how you work that one out. Right, next part. Find the range of values for which that thing is greater than or equal to 5. Okay, we've got an inequality. What you'll want to do here is you'll want to multiply both sides. These are just things with practice you'll just know to do. Sides by the bottom all squared. Okay, so you want this multiplied by the bottom squared. So what you're going to have is 2x minus 3 squared by 3x minus 1 all over 2x minus 3. We're just going to put them in brackets. And then this will be 5 times 2x minus 3 squared. This will make a positive and it'll make the thing work. So that will get rid of our bottom, and because there's 2 of them, it's squared. You're just left with a normal bracket up there. So we can just multiply out our brackets. I'm going to do it in my head. If you want to do it out the long way, that's grand. So we've got 2x by 3x. That gives us 6x squared. Then we'll have minus 2x minus 9x plus 3. So we get 6x squared minus 7x. Sorry, that should be a minus 2x. So minus 11x plus 3 is greater than or equal to, this will be 5 by 4x squared, then minus 6x minus 6x, so minus 12x. And then 3 by 3 is 9. Okay, again, you can do it out the long way if you want, but just for speed. So here we'll have 20x squared minus 60x plus 45. Right, we want everything to be on the one side of the equals. So we need one side to be 0 because this is looking a bit like a quadratic. Okay, that one's positive, so let's move all these things. So minus 6x squared plus 11x minus 3 minus 6x squared plus 11x minus 3. So we will get 0 is greater than or equal to 14x squared minus 49x plus 42. Yes. Okay, so now we've got a quadratic. Let's make it a bit easier on ourselves. Let's divide it by 7 because they all divide into 7. So we'll get 0 is greater than or equal to 2x squared minus 7x plus 6. So you see how much nicer it is now. We've made ourselves a quadratic. So we are going to need to obviously factorize it. So let's get our guide number. We've got our guide number of 12. It'll be minus 3 and minus 4 are the two factors there. So 2x squared minus 3x minus 4x plus 6, 2x, sorry, just x, x by 2x minus 3 minus 2 by 2x minus 3. Would have been easier actually to switch these two around, but anyway. We've got x minus 2 and 2x minus 3 is greater than or equal to 0. So that means 0 is greater than or equal to x minus 2. And we've also got 0 is greater than or equal to 2x minus 3. So your answers are going to be x equals 2 and x equals 3 over 2. Okay, now, so you're looking for when these are less than 0. So remember, you'll have a graph and you want it where it's less than 0. Okay, so it's this section that you're looking for. So x is going to be, so 3 over 2 is also 1.5. Yeah, so this is your bigger number. So x is less than or equal to 2 and greater than or equal to 3 over 2. Okay, that's not very clear on my thing, but this is the answer. So you can imagine on your graph, this is where it's less than 0, here's 2, and here's 1.5. So it's between these 2 points that x is less than 0. Okay, so a bit of an awkward thing, nearly not even enough space there for it, but that's the method you use for that. And finally on this question, this is quite a long question, I maybe put too much in it. Okay, so write down descending powers of p, the first 3 terms in the binomial expansion of this thing here in its simplest form. Okay, so you could start doing Pascal's triangle like this, but you'd have to go down to number 7, and that's just kind of too much effort. So don't forget there's also the method of using the whole 7 choose 0, 7 choose 1, and 7 choose 2 for the first 3 terms, because they'll keep going on to 3, 4, 5, 6, 7 to give you 8 terms. So we only need the first 3. So let's just do the first 3 terms. So 7 choose 0 times 2p to the power of 7 times 3 to the power of 0. And then it'll be plus 7 choose 1, 2p to the power of 6 by 3 to the power of 1. And then plus 7 choose 2, 2p to the power of 5 and 3 to the power of 2. So you can just put the choose thing in on the calculator. 7 choose 0 is 1, 7 choose 1 is 7, and 7 choose 3 is 20, or 7 choose 2 is 21. Okay, 2p to the power of 7 then is, so 2 to the power of 7 is 128 p cubed, and 3 to the power of 0 is just 1, so it doesn't matter. 7, so 2 to the power of 6 is 64 p6, 64 p6, and then times 3 as well, and then plus 21, 2 to the power of 5, 2, 4, 8, 16, 32 p5, and then 3 squared is 9. Okay, so then you just need to multiply these numbers on your calculator. So you will get as your 3 answers 128 p cubed plus those 3 multiplied together will give you 1344 p to the power of 6. Sorry, no, that shouldn't be p cubed, that should be p7. Plus then multiply these 3 things together and you get 6048 p to the power of 5. Okay, it's a fairly quick way of doing it. If you just remember, it's whatever that number is and start at choose 0 and just keep working from there. Okay, you can also do it the Pascal's triangle way. I just wasn't bothered because it went down to number 7. Okay, right. 2 questions to go. We're nearly there. Right, sets now. Probability, I presume. So 240 people were surveyed about which countries they had been to. The Venn diagram shows the number of these countries. So I don't know, we can say it's America, Britain, and China or something. It doesn't really matter. America's not a country. It's the United States. Geography lesson. Anyway, so show the probability of A is 1/4. So PA is 1/4. So that means this whole lot here, that should be 1/4. So in total, how many did it say? There's 240. So it'll be, so we're looking for something over 240. So A is 23 plus 18 plus 13 plus 6. You add them together, you get 60. That's 60 out of 240 people, which is indeed 1/4. Nice easy way to start off that question. So then verify, sorry, I've got this little box kind of stuck up here. I don't know how to get rid of it. Anyway, we're not going to pause. We're going to get this finished. So verify for the values. So PAUC equals PA plus PC minus PA intersection C. So remember, P just means probability. So A union C. So that means we need to add up all the numbers in A and C. So A, we've already done 60, the first 60. So that's all of A. And then union C, so we just need to add 41 and 16. So 41 plus 16. Now, that's equal to the probability of A. So probability of A, that's 60 things. Plus the probability of C, which is, oh, we may add them up. So that's 13 plus 6 plus 16 plus 41. Oh yeah, sorry, and don't forget, sorry, this is probabilities, so you should always have these over 240. So 60 over 240 plus this over 240. My writing is shocking. And minus PA, that N means intersection, so that's 13 and 6. So that's minus 19 over 240. Okay, this is a bit messy, sorry about that. But that is 117 out of 240 is equal to 1/4 plus, then this one is 76 over 240. Actually, I should leave that as 60. 60 over 240 minus 19 out of 240. Okay, if you add these up, you get 7. That gives you 136 there. And then if you minus 19 off that, you will get 126, 117 over 240. So indeed, they are the same. Okay, that's just a lot of reading and adding numbers. Okay, are they independent events? Okay, so this is just something that you need to remember. Independent events. So that means that one doesn't affect the probability of the other. That means, is the probability of A intersection B equal to the probability of A times the probability of B? Okay, so are they independent events? You need to check, is this true? And you just need to remember this. Okay, so A intersection B, did we have that by any chance in the last one? No, we didn't. So A intersection B is 18 plus 6, that's 24. So we've got 24 out of 240. Is it equal to probability of A, which was 1/4, times the probability of B? So probability of B is 56 plus 18, 56, 66, 74, 80. That would be 96 over 240. So that's 96 over 240. 96 over 240, which is actually equal to 4 over 10, which is 2 over 5. So we've got 1/4 times 2/5, and this is 1/10. Okay, is 1/10 equal to 1/4 times 2/5? So, well, let's multiply it. We've got 2 over 20, which is indeed 1 over 10. So the answer to that question is yes, they are independent events, because the probability of the intersection is the same as the probability of the two of them multiplied together. That's just something you need to remember. It's just a word you're going to have to remember. All right, 2 of the 240 are picked at random. Find the probability that one of them had been to all 3 countries and the other had been to none of the 3 countries. Okay, this is one of those times where you have to add different probabilities. So so you've got 2 people, one had been to all 3 and the other. So either you had been to all 3 and then you had been to none, or you had been to none with the first person, and then you'd been to all three. So the probability of being to none of the countries was 67. No, I'll not be a child. So that would be 67 out of 240. No, sorry, that's the probability of none. None is 67. Sorry, none is 67. The probability of being to all three was 6. So 6 out of 240. Now, just the way you have to do this, so all three is 6 and none is 67. Now, in this case, you're picking 6 out of 240 people, and the probability of that happening combined with this. Now, just notice you've already picked one person, so you've only got 239 people left. And your other option here is that it was the none person first, so that would be 67 out of 240 times 6 over 239. So you just need to be careful in these questions. They're easy to pick up attempt marks in, but hard to kind of get right first try sometimes. So anyway, just make sure that you don't mess up that 239 part. Okay, multiply them on your calculator. Naturally enough, I can't do it in my head, but the answer is 67 out of 9,560. And then when you see the word or, you're going to add your probabilities. And this is, well, it's actually also 67 out of 9,560. Okay, it just happens that way. These won't always be the same. So you add them up in your calculator and you will get 67 out of 4,780. So it's basically just half of that. So it's, anyway, do it on your calculator and you see, 6, 7. Anyway, right, sorry, I went off that very quickly. So just if you missed that, that's your answer. Okay, and question 8, we're nearly there now. We've just got some trigonometry to finish off. I actually remember this question. I wasn't actually that happy with it when I was correcting it. It was a bit all over the place. The second bit was nearly more hairy in volume. But anyway, so all 4 solutions. So remember, if you see all 4 solutions and you see one of these funny looking things, you are looking at your cast circle. So that means cos is positive here, all of them are positive here, sin is positive here, and tan is positive there. So in this case, we've got tan 2 theta equals minus 1 over root 3. So that could mean anything, but what you need to do is you need to do tan negative 1 of minus 1 over root 3. Okay, and that will get you minus 30 degrees. So the angle that we are working with is around down here. So this is minus 30. Okay, that's 30 degrees counterclockwise. Now, the only thing is that is tan 2 theta. So our first one, we are going to need to divide this by 2, and we are going to get our first angle as minus 15 degrees. Now, you see here it's between 0 and 360. So what we actually need to do is 360 minus 15. So what's 15 down from here? And you will get 345 degrees. Now, you can use trial and error for all this, tan 2, and then just put it in brackets and keep trying numbers, but this is the quickest way to do it. So we've got this angle is minus 1 over root 3. Now, that means that other angles are also going to be the same. So let's see. We are going to want to go around. If we do 345, sorry, I'm just thinking what's the best way to go about this. I know what the answers are, but okay, so 345 is one of them, but we have all 4 solutions. So think about it. Minus 30 was one of the solutions. If you do a full lap around, you will get back to the thing. It's 360 degrees. So let's just add another 360 to that, and you will get 330 degrees. That's this round again. But again, you need it to be divided by 2 because it's 2 theta. So if you just divide that by 2, we will get 115 degrees. Okay, no, that's not 115, that is 165. It's okay, we can make it to the end of this video. Okay, so that's grand, but then we will also have an equal angle. So we want it to be negative, so that means we're working with this section here for tan. So this would be, there'd be about 30 degrees there, or in total it would be 150 degrees, because that would be a straight line, 180. So we want tan of 150, again, divide it by 2, and you'll get 75 degrees, and then 150 plus 360. To do another full lap, we get 510. Let's Let's divide that by 2 as well, and you will get 255 degrees. Okay, it's easy to get the first one. It's just working out the rest of them can be a bit awkward. So these are your 4 answers. I have them all over the place. So we have 345, 165, 75, and 255. Those are your 4 answers. Okay, and let's go to the last page. We got this now. Okay, I didn't overburden you with trigonometry in this exam, but anyway, so we've got a quadrilateral. You can see there's a right angle here, so we're probably going to be using Pythagoras or SOHCAHTOA. You've also got a triangle here, probably looking at the cosine rule there, although actually I don't think you need it for this question. So we've got lengths given here, which are in the diagram, 70 degrees. So find dB, the length of dB. Okay, we've got a triangle, we've got a right angle, so let's just Pythagoras this. So it's going to be the square root, and you're missing the long side, so you just have to do 2.5 squared plus 1.8 squared. I'm just doing it the shorthand way, and that will give you 3.08 centimeters. You can do the whole thing where you like add them and then square root it, but that's quicker to stick in your calculator. Okay, find the area of triangle ABD. So that's ABD. Okay, we've got a right angle, so we can actually do this a nice easy way. It's a half the base times the height. So that's a half 2.5 times 1.8. That will give you a nice 2.25 centimeters there. Sorry, area, that's centimeters squared. Just be careful to make sure you get the things right. Then hence, find the area of ABCD. Okay, so for BCD, let's just, okay. Sorry, it's way zoomed out. So we've got 70 to 1.8, 2.5. Okay, so to find the area of that, you've already got the area of that. So that was 2.25. And you have the length of DB, which was 3.08. Okay, so now we actually have a triangle here with 70 degrees, 2 here, and 3.08. That's all centimeters here. So we can use a half AB sine C for this. So a half 3.08 by 2 by sine of 70. Stick that into your calculators, you will get the area. It is 2.89 centimeters squared. And you just need to add the 2.25 to that, and you will get your final answer of 5.14 centimeters squared. Okay, I know I did that fairly quickly. I just wanted to be finished, to be perfectly honest. But yeah, that gets us to the end. You're using a few different things, a bit of area and a bit of trigonometry there. So there is your answers there. You just get the 2 areas and you add them together. All right, and I think that will do us then. That is the end of the video. So well done if you have actually made it this far. I don't know, you should tell me in class or something if you've actually managed to get to the end. Say that like you like cows or something, just to prove it to me that you got to the end. So anyway, I'm going to stop. We're at 33 minutes, so that'll do us. Good job.